Let's consider a bar magnet. Its shape is similar to that of a chocolate bar. It has two ends on the opposite sides where N and S are written. Do the ends have any significance? These two ends are called the poles of a magnet. The one where N is written is North Pole and where S is written is South Pole. We now know that there is an invisible magnetic field surrounding it. And if you place any magnetic material in this field, then it will be attracted towards the magnet. But this field is invisible to us. However, there is one way in which we can visualize it. How? Tie up this magnet with a piece of paper with the help of a sellotape. Keep it on the table and turn it upside down so that the magnet is on the lower face of the paper. The magnet is between the paper and the surface of the table. Mark the position of two poles of a magnet on the upper face. This place is above the North Pole and this one is above the South Pole. Finally, sprinkle some iron filings on the upper face slowly so as to cover the entire area surrounding the magnet. What will we notice? We will find that the iron filings arrange themselves in a specific pattern. This pattern not only shows us the pattern, but also tells us a lot about the strength of the magnetic field of a bar magnet. First of all, iron filings are nothing but very tiny pieces of iron, which is a ferromagnetic material. So they are attracted by a magnet. You will see that more iron filings are gathered at the two specific locations and less elsewhere. These two are the locations directly above the two poles of a magnet. So the iron filings are attracted more towards the poles of a magnet than the center. But what does this tell us about the strength of a magnetic field? More iron attracted at the poles means that the field at the poles is stronger. And consequently, the field is weaker at the center. Not only a bar magnet, every magnet has a different field pattern. This field pattern depends on the shape of a magnet. Yes, different shaped magnets have different field patterns. For instance, here is the field pattern of a horseshoe magnet. You can see that more iron filings are gathered around the two poles while less so elsewhere. In the next video, we will see different types of magnets. See you there.